You know that feeling, right? You just drop your phone on a charging pad and poof, it lights up, it's charging. No cables, nothing. It feels like straight up magic, doesn't it? Well, today, we're going to pull back the curtain and show you the real science behind the trick.
So, the big question on everyone's mind is, what's actually happening here? Is electricity literally flying through the air from the pad to your phone? I mean, it kind of seems like it has to be, but is that the real story?
The answer, in short, is nope, not at all. That's probably the biggest misconception about how this all works. And trust me, the real story is way more interesting. Yeah, we're not talking about tiny lightning bolts zapping your phone. The real secret here is an invisible, powerful force field, and it's doing all the heavy lifting. So let's break down what that actually means. All right, first up, magic or misconception. Let's dig into why that first idea, electricity just flowing through the air, is a total non-starter. Okay, so the main reason is actually pretty simple. Air is what's called an electrical insulator. Basically, it's really, really good at stopping electric current in its tracks. And thank goodness for that. If it wasn't, our whole power grid would just be a chaotic mess of sparks everywhere. But here's the twist. While a direct current can't just flow through the air, energy totally can, and it has a few ways of doing it. You've got electric fields, you've got magnetic fields, and you have electromagnetic waves. And for wireless charging, well, it definitely has a favorite.
And the winner is magnetic fields. This is the key to the whole thing. We're not sending electricity through the air. We are sending energy using a very specific, very localized magnetic field.
Okay, so that's great, but how do you turn a magnetic field into actual battery power? Well, for that, we have to go back in time and thank a true giant of science, Michael Faraday. He's the one who discovered this incredible invisible link.
The principle he discovered is called electromagnetic induction, and the most important word there is induction, which is all about change. Think of it like this. A perfectly still, calm lake doesn't have much usable energy, but a lake with waves, now that's a different story. A static, unchanging magnetic field is just like that calm lake. It's not going to do much. You need a changing, fluctuating field to actually generate a current.
And that's the core of what Faraday figured out way back in the 1830s. This one single idea, it's the foundation for so much of our modern world. I'm talking everything from giant power plants to, the very device you might be wirelessly charging this very second.
And look, this isn't some weird, exotic, newfangled physics. You've actually seen electromagnetic induction at work your entire life, probably without even realizing it. Those big transformers on power poles? That's it. The generators that create our electricity? Same thing. Even those cool induction cooktops that can boil water without a flame, they all run on this exact same principle.
So let's put it all together. Let's walk through the whole process step by step. First, alternating current, or AC, from your wall flows into a special coil in the charging pad. That's the transmitter. Second, because that current is constantly changing direction, it creates a changing magnetic field all around that coil. Third, that magnetic field then radiates out, but only for a very short distance. Fourth, when you put your phone down, a similar coil inside your device, the receiver, catches that changing magnetic field. And that, in turn, induces an electric current inside the phone. And finally, step 5, that brand new current charges your battery. See? No wires, just physics.
All right, so that's the science. Now let's get practical and talk about the rules of wireless. The stuff you actually deal with day to day to make this work.
I'm sure we've all been there, right? You tossed your phone onto the charging pad, you walk away, and nothing. You have to nudge it around, find that one perfect sweet spot. So why on earth is it so picky?
Well, it all comes down to efficiency. For this to work well, those two coils, the one in the charger and the one in your phone, have to be lined up almost perfectly. See, that magnetic field is strong, but its power drops off really fast with distance. We're talking millimeters. So if the coils are off-center, the receiver coil in your phone just can't catch enough of that magnetic field to get a decent charge going. And this also helps clear up a common point of confusion. Why is this so different from something like Wi-Fi or radio? I mean, they're all wireless, right? Well, they're built for totally different jobs. Wi-Fi and radio use low-power electromagnetic waves to send data over long distances. Wireless charging, on the other hand, uses a high-power magnetic field to send energy over a super short distance. One is for sending information, the other is for sending raw power.
And like pretty much any technology out there, it's a game of pros and cons. The upsides, oh, they're great. It's super convenient, right? No more fumbling with cables, you're not wearing out your phone's charging port, and it's way safer in places like a kitchen or a bathroom. But there are downsides. It's almost always slower than a good old-fashioned cable. The process isn't perfectly efficient, so some energy gets lost as heat. And of course, there's that need for precise placement we just talked about.
But it's really easy to think this is just a smartphone thing, and it's so much bigger than that. So let's look beyond the charging pad and see where else this invisible link is popping up.
The applications are honestly amazing, and they range from the tiny to the absolutely massive. You've probably got one in your bathroom right now, your electric toothbrush. That sealed base with no metal contacts, that's wireless charging. It's also used for life-saving medical implants, which is incredible because it lets them be recharged right through the skin, no surgery needed. And then you scale it all the way up, and they're developing pads to charge electric cars. I mean, just imagine parking your car in the garage and it just starts charging, no plugs.
So if you take just one thing away from all of this, let it be this. It's not electricity flying through the air. It's the elegant transfer of energy through a focused magnetic field. It's physics, not magic, all thanks to an idea from nearly 2 centuries ago.
And that just leaves us with one final thought to chew on. As this technology gets better, stronger, more efficient, as it lets us send more power over greater distances, what comes next? We cut the cord on our phones, cars might be next. What do you think is the next cord that we as a society are going to cut forever?